Okay, now let's talk about triggers. One thing that I've peppered throughout some of my discussion, and I've also put in a couple of links, is that MySQL does not support a lot on constraints. Check constraints and assertions are not supported. They will compile, or they will not throw errors. They will parse, but they will not actually execute and do the necessary protections you need. That's just one of the natures of the implementation. And it's not really well documented because it is listed in the syntax. It's part of the it supports SQL's standards. However, it's just not there. Triggers, however, are often referred to as a good workaround for that. However, they can do so much more. So basically, triggers are rules within SQL that divide things up into an event that occurs, a condition of that event, and then action if those conditions are met. So what could an event be? Well, an event could be an update, and that update could be at the row level, it could be at an attribute level. It could be an insert, it could be a delete. So anything that involves the database changing can be treated as an event. Now, the action of this database or, assertion or trigger, the action of this trigger can either happen before the database is modified or after the database is modified. So you could potentially intervene and change things before the database is actually changed, or you could go in and make changes after whatever triggering action has occurred. So first of all, let's talk about these components again. An event is the event being executed by SQL that awakens the trigger. The condition is the condition with which that determines whether or not the system should act. The action is how the system should respond, which is usually some set of one or multiple SQL operations. So the key features is that the trigger can happen before or after the triggering event, as I already said, and we'll use the keywords before and after to define these. So, as I said with before, it lets you respond by performing some sequence of operations. Then whatever had caused this triggering of events will actually make its write and its commit. If you do after, whatever that triggering event does, it has been done, and then you are responding to it in some way. Conditions can reference both new tuples or tuples in the old table. So that's actually neat. You can actually specify which tables you're referencing, and you have to define whether or not you're working with the old or the new version of the tuples or new or old versions of the relations before you can actually clearly specify your conditions and such. And they can be triggered to execute either row level or statement level, and we'll get into more detail on that here in a moment. So let's break down the anatomy of a trigger. So here you can see I've kind of got a definition of each of these components that make up a trigger. So we have create trigger, so that's the declaration that the trigger has begun. We then set net worth trigger as the name. Here is the before or after statement. We're saying after the so everything that's going to happen down in this when after the when statement, basically this stuff right here, this is the change stuff. All that will happen after an update has occurred of net worth on a movie executive. So the net worth will change from an update event will occur, and then this will be triggered given the appropriate conditions. Now the conditions are going to be based off of the old row and the new row. So if we change some net worth, that impacts some row in movie exec. So we want to grab that entire row before it was changed, and we'll call it old tuple. And we'll grab that whole row for the new version, and we'll call it new tuple. Then this is going to be for each row. So for each row indicates that this will occur on every row updated by the trigger. Alternatively, for each statement would have stated the trigger would happen once for all impacted rows. So in this case, what that means is if I do an update and it say impacts 5 rows, then for each of those 5 rows, it's going to do the check and then the response if the check passes. If, on the other hand, we have it being for each statement, then whatever happens with the check, the conditional, and the response only happens one time. Okay? So now we get to when. When defines the start of the conditional. Old tuple.networth is greater than new tuple.networth. So anytime the movie's executive's net worth drops below the old amount, we then have to respond. So here, we then update movie exec with set net worth equal to the old net worth, where the certificate number equals new tuple.certificate number. So this seems kind of weird, but what we're doing is basically we're making it where it's impossible for a movie executive to have their net worth lowered. It can only go up. So anytime you say take some executive, say George Lucas goes from, 1.5 billion down to say 1.2 billion, well, it would chop it and then say, nope, you're actually 1.5 again. It would take the old value and reassert it, undoing the change that had occurred in new tuple. Now that's important to note that this is happening after, because if we had done before, well, we would have reasserted it, but then it would have been overwritten by the triggering event. But we're doing it after, so the triggering event is going to knock it down, and then we raise it back up by reasserting the old value. Okay. So the above example is only limited to one case, so we have some additional cases. So we talked about before and after, and I think this is a little bit redundant from what I covered earlier, so there's no point in me kind of restating it now. So it's just before or after the event on when the when statement is processed, when the when statement is processed and the response occurs. So does it happen after the triggering event or before? Types of events can be update, insert, or delete. If it's an update, it requires the identification of the attribute that has changed using the of clause. So if we scroll back to this previous example, after update of net worth. So the of tells us then that the following will be the attribute changed. If it's an insert or a delete, there is no of clause, but both of these, or all three of these, require the on clause, on which table. So in this previous example, on movie exec. The when clause is optional. You can have this occur any time that the update occurs. We just happen to be doing it on the condition where if the old net worth is greater than the new net worth to do something. So if the when clause is present, it must be satisfied for the trigger actions to happen. If the when clause is not present, it automatically occurs. And you can have multiple SQL commands in that bottom part. So in this case, we just did a single update. However, you could do an update, an insert, a delete, a drop table, any sort of thing within that context. If it's multiple commands, however, you have to do begin followed by a sequence of operations followed by end. You can leave that off if you are only doing one. I already talked about for each row versus for each statement. So for each row, the action is performed for every row that is triggering the event versus, okay, hold on one second. Okay, typo alert, where it says for each row here on the second bullet, that should be for each statement. Because for each statement, if that's set, then the action is performed once, regardless of how many tuples are impacted. So I don't have a markup tool here, I don't think. Let me see. No, unfortunately, I do not have a markup tool, so where it says for each row, please change that on your notes to for each statement. Here we have referencing, which can be included, which notes that updates providing access to both old and new tables. So that's where we had our referencing clause up here. I'm not quite sure why these are a little bit out of order, but referencing, basically we can say old row and new row as options. So if we have a for each row type operation, we can use old row or new row, or we could use old table and new table. So we have the flexibility of either saving or accessing the old row and the old table. If we do for each statement, we can only access the old table and the new table. We can't access any individual rows because that would be nonsensical. The for each statement is handling all of the events that were occurring by the trigger as one, therefore we can't isolate the individual things. So with referencing, for update, it provides access to both the old and the new tables. For a delete, it provides access only to the old table and only rows. For an insert, it provides access to the new table and only those rows as well. So let's look at another example. So here we have trigger average create trigger average net worth trigger. After update of net worth on movie executive, referencing old table as old stuff and new table as new stuff for each statement. So notice now we're using tables and we're using statement instead of for each row. When we have, what is that? 500,000 is greater than the average net worth from movie executives, we have to respond. So we want to sum up the entire, or we want to average the net worth across all the movie executives, and if that result is for some reason less than or equal to $500,000 total dollars, then we need to act. So our action is basically to undo that change. And the way they undo it is, first of all, they delete everybody that is in new stuff. So if your name, address, certificate number, and net worth is in new stuff, your row is deleted. Well, since this is an update, really every movie executive in old stuff is also in new stuff. It's just something has changed with their net worth. Regardless, this just deletes everybody. So everybody's gone. But we still have old stuff saved, and that was the old state prior to this update occurring. So what we do now is we insert into movie executive all of that old stuff. So when it's done, everything looks like it's back to normal. Okay, now let's walk through one final example. Let's be quick about this one. We're low on time. So first of all, we're going to create a trigger called fix year trigger. We're going to be doing it before we do an insert on movies. Here, with the referencing, we are referencing new row as new row. So that's the row that we're inserting. And new table as new stuff. Well, since this is before and it's an insert, new stuff is only going to contain the new tuple. So then we have our for each. So for each new insert into movies, if the new row.year is null, we then set the year to 1915. So first of all, this is very odd. Why would you change an entire table's year since we don't have a where clause on this? Because one is null. Well, in this case, it's because of the nature of the beast, where we're doing a before insert. So we're only having one row here and then one row here. So it doesn't matter. But typically, you would not do this. The key thing that this example shows and what makes it neat is it's a way to circumvent a constraint. If you have a constraint where something is a primary key and it's not allowed to be null, well, here you could detect that you've got a null with an is null, and then you could replace it with a default value. Obviously here it's just pulled out of thin air, but think about other applications where you might have a meaningful default value, and think about this as possibly a prototype on how you could work around that. Alright folks, that is all for today. Thank you and goodbye.